Good morning, Joseph.
Good morning. Good morning. Apologies for the delay. I was just having a bit of an issue, but all set now.
Okay, perfect. We were scared that you didn't hear your alarm clock.
Oh, no.
Early in the morning.
Quite some time, don't worry.
Okay, perfect. Okay, so yeah, hello everybody. Welcome to this session. We have the question, what makes a good data scientist? And I'm happy that you are both here, Oleg and Joseph, so welcome. We already talked a little bit about this. So at Joseph's place, it's early in the morning. He drank some coffee and now he can wake up with his talk. So it would be nice if you two could, before your input, just briefly say a few sentences about yourself and then, show us what you got. Oleg already said that you both basically don't really know what the other person is exactly talking about. So that's also a surprising debate. And yeah, people in the audience, please feel free to just write down your questions or comments, remarks. And then after the input, we will have a small conversation, maybe a debate, discussion, something like this. So I'm looking forward to it. So I mute myself now and also disable my video. So the floor is yours, Joseph.
Okay, fantastic. Yeah, thank you very much for the quick introduction. So my name is Joseph Edelsack, and I'm the Business Development Manager here at DataQuest. For those who aren't familiar with DataQuest, we're one of CorrelAid's partners. We are one of the leading learning platforms online for developing data science skills that will help you to build a future career in data science. And like it was already said, I'm joining today from the East Coast of the US in a small town called Pittsburgh. Personally, I come from a background in education technology, so I've worked at some other relatively well-known technology companies before coming to DataQuest. And yeah, hopefully I'll be able to, elaborate on the topics that we have for the discussion. So yeah, Oleg, if you want to go ahead and introduce yourself as well.
Well, it's very nice to meet you, Joseph. Hello, everyone. My name is Oleg. I'm a data scientist based in Amsterdam. I worked as a data scientist and data engineer in a few European startups. And in the past few years, I was a data science manager at Uber. And in my career, I applied to many data science jobs as a candidate. And I always hated it when I got rejected, but didn't get any feedback after interviews. So I started helping other data scientists prepare for job interviews and, most importantly, receive actionable feedback that helps to understand what you're good at and where you can improve. And today I will talk about data science competencies and hiring process, and I will share some tips on how to get a job as a data scientist. Over to you, Joseph.
Perfect. Sorry about that. My apologies. That was odd. Yeah, my computer just decided to kind of do that. Okay, so thank you. I appreciate that, Oleg. So let's go ahead. I'll get started here by just pulling up a couple of things. So really what I was hoping to talk to you about today is essentially DataQuest's approach to training and educating future data scientists, and why we believe that this pedagogy will yield really great results with your learning and will lead to a successful career in data science as well. So to begin, the first topic that I wanted to cover with you really was essentially teaching with video versus teaching in kind of an interactive way. And within the realm of not just teaching data science, but any type of skill, really, there's an age-old debate about lecture-based learning and its effectiveness. So lecture-based learning obviously has been around for centuries, and it's the most common type of way still to teach skills online. A lot of other platforms out there that I won't name specifically are still using this type of method, and they have thousands and thousands of hours of video lectures that are stitched together, often with fill in the blank and multiple choice quizzes at the end, something like that. But what we were trying to work out when we first started DataQuest was to decide if this was an effective way to learn, or if there were potentially other more effective ways that we could use to bolster the learning experience. So there was a study that we used back in 2018 that we've referenced a lot in the work that we do when we build these courses where basically researchers asked a group of students at MIT to sign up for a learning session that was to be held online, and they split them up into two groups, one consuming the session via solely video, and the other group reading a video transcript, so text of that video, with some other diagrams and some other supporting content. So the morning after the session, both groups took an assessment to test their comprehension and their retention, and they responded to a survey as well about the learning methods that they preferred. The researchers themselves hypothesized that the students would prefer watching the video over doing the reading, and that video watchers would also score better on that exam. Well, as you could imagine, they found precisely the opposite. Most students actually preferred the reading over the video, and students who had read the material rather than watching it performed slightly better on the post-learning assessment. So what we're seeing here is that basically reading alone isn't enough. There's a much larger body of science that that tells us that the important element here is actually going hands-on with your learning. And yes, absolutely, I can provide some citations to that as well. So to give you some examples here, there were some meta-studies done in the 1980s that showed that with groups of high school students, hands-on learners performed on average 20% better than the students who had learned via a more traditional lecture-based approach. And more recently, back in 2014, there were some further meta-studies that found specifically within STEM courses that students who solely learned passively via a video lecture were 1.5 times more likely to fail than other students. So obviously, learning via video doesn't preclude you from applying that knowledge in any way, but we do believe that it makes it a little bit harder today in a few very particular ways. So we think, for example, that going back and trying to review video that you've already been through before is a bit challenging to do as well. And in addition to that, it can be kind of a time-consuming process. It also doesn't really lend itself to getting, obviously, any sort of feedback when you're putting in responses into the system. So what we've tried to do, on our end at DataQuest is to try to make the platform as interactive as possible. And the way that we do that is basically by getting people to code directly within the browser immediately from the time that they start their first course. So even if you're doing the most basic, if, for example, you're joining us with very little experience in data science and you're just starting out with even maybe a programming language, you'll see examples of how to actually code within that programming language from the very, very beginning of any of our courses. And students that we talk to really enjoy that. So in my own experience working at DataQuest, there's a lot of learners who come to us from other platforms where they have not been as successful. A lot of folks out there within this space have tried lots of different platforms. And when they finally come to us, what they tell us is that the fact that we teach interactively and not with any video is one of the main reasons why they left previous platforms and why they came to us and why they continue to study with us. So if you are the type of person that learns very effectively in a hands-on way and you prefer learning without video, I definitely think that we're the right solution to do that, but certainly there's other solutions out there that I would encourage you to look at that also take this approach. So to summarize that whole idea, basically, video lectures are the foundation to a lot of online courses right now, but to be honest, we don't think that they work as well as they could. Videos tend to separate the learning process from the actual practice of the data science, and they can tend to make retention more difficult as well. So they also take a while to go through, and they don't allow you to skim through the material as easily, like I mentioned, and they can sometimes trick you into having captured information that maybe you haven't actually solidified yet because you haven't had to apply it in a certain way. So we really do believe that the application of these skills and doing them in practice is really one of the most important aspects of learning. So this is what I'll come to. The next topic is learning by doing. So we really encourage you to get your hands dirty within data science and be ready to make mistakes as well. I'm sure that Oleg will have some commentary on this for you in a few minutes when he goes through his topics, but we're really big proponents of getting hands-on and learning by doing, and particularly being ready to make mistakes. So if you're really new to data science, or even maybe some other languages or tools like Python or R, you'll learn very quickly that it's rare that you're going to get the right answer the very first time. To be honest with you, even if I make a script and I run my code the first time and it just compiles and works, I typically assume that I've done something wrong, because that's typically pretty unexpected. So even for many veteran data scientists, it's likely going to take several iterations of working through a problem before they'll find the answer that they're looking for. So I believe that, at least on our platform, we've really tried to foster an environment that encourages you to make these types of mistakes by being able to give you immediate feedback on the code that you're running, and show you real errors that you'll be able to see out in the real world, so that you'll know how to approach them when you encounter them. And of course, how to interpret them as well. So we believe in teaching in a way that encourages you to learn from those mistakes that you're making and solidify those skills over time, rather than trying to get you to the exact right answer right off the bat. We believe that over time, in teaching this way, we're building data scientists that are willing to try and potentially fail at a problem repeatedly, to learn from their error and try again. So in addition to kind of that interactivity part, really what I'll say is that we do want folks as well to take these skills and begin to apply them in real ways. And that's kind of one of the ways that we make this platform really interactive and really relatable as well, is by essentially building lessons around answering applicable data science questions using real world data. So students studying machine learning, for example, will learn how to predict airline accidents, for example, using data that we've put onto the site. Learning statistics by looking at sports data, for example, within the world of football and whichever your preferred league is. So these are the types of things that we encourage folks to do as well, not only on the platform, but on their own, is that we want you to synthesize these coding concepts into solving real data science problems, just as you'll do within potentially your work environment or within your personal life as well. So that brings me to sort of the next topic, which is relating it to the real world. So we don't want you to learn skills in a vacuum, since that's not how you'll be applying them in a vacuum either. We want you to apply the skills you're learning to solve problems either in your work or, say, in your personal life in topics that you enjoy. And that practical experience, we think, is really key, because when you relate it to something that you enjoy, you'll be more motivated, you'll more readily come back to that topic, and you'll want to continue to try to develop new skills to solve those problems in new ways. One anecdote that I'll give you from a student that I was just talking to the other day, he told me that after he went through some of the courses in Python, he was actually later, after he finished the course, was looking to buy a home and use a script to essentially pull data from an API of a popular real estate site in order to pull all of that data into one place and do some analysis on what homes would be of most value to him and what homes are maybe overvalued based on his criteria. So he was able to take his learning that he had primarily done for the purpose of his job and apply it to something that was very related to his life specifically and to his personal life, which was looking for the right home in his area. So the last thing that I'll comment here before I pass this over to Oleg is that what we really encourage you to do depending on the types of roles that you're going into, is to build a project portfolio. And employers are really going to want to see some of the work that you've produced related to the skills that you've developed, obviously to show that you've been able to not only apply them and that you can prove your skill in that area, but they also want to see, some level of passion that you're putting forth to build out these projects on your own, and that you're motivated to do that on your own, potentially even outside of the work context. These could be, being prepared to show a project that you've worked on in GitHub, and within that you should be ready to walk them through your thought process for how you actually approached that problem and how you carried out the solution. So employers do really want to see that you've taken the skill and applied it in a way that you can discuss, and it shows that you're thinking about and engaging with these problems regularly. And it will also show that you can approach a variety of different problems in different contexts and still come up with clear and useful solutions. So to kind of summarize, just everything that I've mentioned here so far, what I really believe, I think there's kind of 5 main steps that we would see as how to kind of become a data scientist. So if you'd like to take down these 5 steps, I'd encourage you to take some notes on this. The first is obviously in a very micro sense, learn the basics of programming. Start in a place like R or Python. Those are very commonly used languages out there in the world. They're very commonly used specifically within data science and data analysis, and it will help you to expand on those skills later on as you begin to learn maybe more details of those different languages, or maybe packages within those languages and how to use those packages to solve your problems. Step 2, start building those projects. So like I mentioned, start early. Make sure that you're documenting your process. This is going to solidify your skills, keep you motivated, and will help you with your applications likely in the future. 3, start to then add some more advanced technical skills. So potentially that could be working into other areas like SQL, statistics, the command line, or other areas that are going to be related likely to what you'll need to do on the job. Step 4 is share your work and engage with your community. So definitely, the fact that you're here today is fantastic and tells me already that you're engaging with the community. But learning to sort of collaborate and build a personal brand as a data analyst is really fantastic. I know that it can seem intimidating to put your work out there in the world and share it either on LinkedIn or GitHub or other platforms and talk to folks about what it is. But certainly we encourage you to do that because, again, building that network of community is going to help you to build relationships that will likely help you along with your career as well. And lastly, step 5 that I highly recommend is to push your boundaries. So once you've actually mastered the basics, be sure that you continue to push those boundaries with new projects and new skills that you haven't developed yet. So don't fall into the trap that some people will end up in of doing similar projects over and over again with the skills that you've already built up that you're very familiar with. Go out there and find something that you have no idea how to approach or no idea how to begin with and start trying to attack that problem. Try to include at least one thing that you've never done before in each new project, and you can try to go back to old projects as well and see if you can improve on them or add complexity to them with the new skills that you've developed. So with that, that's everything that I wanted to cover with you today. I really appreciate your time, and I do hope that you check us out, but certainly at the end of the day, I'd like you to work with whatever data science learning platform is most effective for you. So I'd encourage you to go out there and learn in whatever way you see best fit for you.
Thank you, Joseph. That was pretty hands-on. So I'm very excited if Oleg comes up with different steps, or I don't know how to say that, but looking forward to your presentation, Oleg. And thanks, Joseph.
Yeah, thank you, Joseph. This is a great talk. I actually completely agree on everything you said about the only way to learn is to practice, right? and it applies to everything. I remember learning English and my teacher telling me that if you read the book, you learn how to read the book in English, but you don't learn how to speak by reading, right? So if you want to learn data science and you watch videos about data science, you learn how to watch videos about data science. If you want to learn how to do actual data science work, you probably want to practice by doing and find some real projects for yourself. I see we have a few more people that joined us in the past few minutes, so I will quickly reintroduce myself and also share my screen and presentation. I hope you're seeing my screen now. If not, please let me know. I'm a data scientist. My name is Oleg. I'm based in Amsterdam, and I help data scientists to prepare for job interviews. And we see that helps you to understand what you're good at and what you can improve in order to increase the chances of getting a job. I'm going to start with this common meme about expectations and the reality of being a data scientist, because job descriptions often tell us that we will be working on some complex deep learning projects using cutting-edge technologies, and in academia we are told about complex math problems, and in reality we often spend days or weeks just debugging some SQL queries or browsing Stack Overflow to find some errors that we have in our code. And there is a common expression about data science as a role, some role between software engineering and statistics. But if you look up 10 random data science job postings, chances are that some of them will have nothing in common. And that's where the idea of competencies comes in. Different companies might have different views on it, but in general, we can split our technical skills into a few core competencies where business acumen or the domain knowledge is the ability to choose the right metrics, estimate the impact of product changes, design experiments. Analytics stands for discovering insights and supporting decision-making with some exploratory data analysis, and it can include skills like data wrangling, SQL queries, data visualization, and storytelling. Statistics is for probability theory and statistical tests for causal inference that can be applied for experiment analysis, root cause analysis, and impact estimation. Modeling is anything about machine learning, data preparation, implementing models, evaluating the models. And last but not least is coding that covers understanding of algorithms, programming languages, and coding best practices. And as you can see on this chart, there can be two very experienced data scientists having very little in common. Both of them can be very valuable in their own teams and good at the work they do. But essentially it means that there is no single score describing you as a good or bad data scientist. And it's more about the value that you can bring to a certain project and how well these competencies are matched between you and the project. And it also means that from a job search perspective, interviews are not exams. And if you get rejected after applying for a job, it's not a signal that you are not good enough, but it's a signal that perhaps there is someone with more relevant skills for a certain role in a certain team. And I'd like to focus a little bit on the hiring process for data scientists. And the exact pipeline might be different in different companies, but most of the time it includes these three components of your CV screening, job interviews, and the final decision that is made by, usually made by hiring manager on some debrief. And if any of you work on some ensemble models this morning, you probably see it as an ensemble classification model, because these are three classifiers, and the interviewing stage itself is an ensemble model where the results of each interview are aggregated to predict the final outcome. So hiring is a predictive problem, but the outcome is hard to define and even harder to quantify. And because we don't know what would have happened in the parallel universe if we joined a different company, if we hired a different candidate, we can't really run an A/B test with that. And the reason I wanted to focus on it is that we as data scientists have experience in building predictive models like this, and we can actually apply our knowledge to help us get the job that we want. So let's dig a little bit deeper into these models and think about them from the machine learning terms. So for example, our background and our experience is the data, a large amount of unstructured data stored in our memory. And the way we present this data in our CV and the way we answer interview questions is the process of feature engineering. And this is actually something that we can control. And on the other side, we have the model itself that we don't have control over. But for example, when a recruiter spends several seconds looking at your job history on your CV, they usually have some fast and simple rule-based thought process that checks for numeric features like number of years of experience that you have, some categorical features like whether you mentioned relevant technology names, for example. What is really important about these models is that they lean a lot towards minimizing the chances of false positive error, that is hiring a wrong person. And they don't focus so much on false negative errors, which is rejecting a good data scientist that would have brought a lot of value to the company, but we will never know. So what can we do as data scientists to help this model make the right prediction and potentially get a job? And it turns out the same principles that we can apply when predicting user retention or house prices for any other classical data science problem can be applied here as well. So first, we care about feature relevance. And it means that, for example, in our CV, we want to focus on the most important and relevant facts from our job history. And we want to remove features that can only add noise and bias. For example, our photo or home address or detailed information about our job experience from 10 years ago that is not relevant to a role that we're applying for. Another thing is, and it's not really about feature engineering, but I still want to talk about this, is the data itself. And we control the data, we control our background and our experience, and we control the way we present this data on job interviews and in our CV. So let's think about typical data science problems in the data preparation space. And cold start, for example, is a very common example when we don't have initial data to kickstart the model. And in the hiring context, cold start problem is essentially when you have very little or no experience to show in your CV, but you still want to get a job. And if you are building a machine learning model, there can be certain ways of solving these problems. You can prepare some synthetic data set, for example. If you are applying for a job, you can prepare some synthetic data set and some synthetic job experience. And this is actually what Joseph elaborated a few minutes ago. I think he provided a few very good examples, because I think if you're a data scientist, you can see data science problems everywhere. If you're looking to rent a house, then you can just get the data about house prices and find some houses that are undervalued and that fit your requirements well. If you're a fan of football, you can get some goals data and some player statistics to predict who will win the Prime League this year. If you like movies, get some movie data and predict IMDb ratings. Anything. Just be creative. And being creative, finding problems, defining the problems, finding the data is a part of our job. It's not just about the last part of building a model when you already have the data, when you know what is your accuracy metric that you are trying to minimize or maximize. It is the part of our job, finding and defining problems that can be solved with our data science skills. You can also, this is CorrelCon, so you can always find some projects from CorrelAid if you have enough experience to work on them. You can always go to kaggle.com and other data science competitions, but this is an easy way to practice the modeling part of the job, ignoring the problem definition part of our job. So let's talk a little more about the process of building a machine learning. So we never stop after running a new model that we just built once, right? So you build a model, you run it on a trained data set, you run it on test data set, you look at some metrics, you tune a few things, and you just keep repeating this process over and over until you are satisfied with the results. So if we follow the same analogy with the job search process, it would mean that we apply for a job, we interview, we get some feedback at the end, get rejected. The next day we apply again, tune a few things, change our interview questions, get rejected again, and keep applying until we get the job in this company. Unfortunately, this is not the way job search works, so we cannot do it. But we still want to get some feedback, and we still want to improve because we want to know why we were rejected. And there is a solution to it called mock interviews. Essentially, you still want to practice interviewing, you want to receive feedback, even though you cannot apply to the same company multiple times. But you can just ask your friend to, they are interviewing you, and ask you some standard data science questions and share their feedback with you after this mock interview. You can also interview with the chatbot on NextRound.cc. This is my website where you can go and complete a free mock interview and receive actionable feedback based on your answers that will help you improve and prepare for actual job interviews and get the job that you want. So that's about it. Quick recap. I don't think there is such a thing as a definition of a good data scientist as a list of skills. A good data scientist is rather someone who brings value to their team and their project by applying their data skills. I know it's a very vague definition. Interviews are not exams. Hiring is a predictive problem, and this is something we are good at, and we can apply our expertise in data science to help us get the jobs that we want. Practice makes perfect. Feedback is the key. If you want to increase your chances of succeeding on job interviews, you should practice interviewing and not just reading blog posts. And if you want to get a data science job, succeed on job interviews, all it takes is just a little preparation. And I think now we'll have some time to answer the questions and have a discussion about education data science with Joseph and Isabel and you. If anyone has any questions or needs help preparing for interviews, feel free to send me an email or visit NextRound.cc for a free mock interview.
Perfect. Thank you so much. Yeah, so please, audience, if you have any questions, feel free to write them in the chat. There was already one where for you, Joseph, actually. So Lena doesn't know DataQuest, and she knows DataCamp, and asked if there's, like, what's the difference between the two platforms. Maybe you can answer that. And thank you, Oleg, for your presentation. It was really, really nice.
Yeah, so I could try to give kind of a brief summary of how we usually talk DataCamp versus DataQuest, because a lot of people, you know, for full transparency, I would say that DataCamp is probably, you know, 5 times as popular as we are online, just in search results and other things. So it's going to be more well known out there. Maybe more of you in the audience have heard about it, but the main difference, I would say, is that what you'll find with our courses and kind of the level of interactivity is that we're giving you, hopefully, some feedback on when you write a piece of code, for example, and it's set up similarly in that you have kind of your information, your text-based information on the left, and you have your sort of coding environment or your text editor or what have you on the right. And when you go through and you write your script, for example, and you run that code, what it will tell you, first of all, is, did it compile? Does it actually get to the end and work or do anything? And so it will tell you one of the other ways on our platform and on their platform as well. What, as I understand it, it will not tell you is to give you some more information about if it did run, what feedback can they give you about the error that they may have encountered, what that output looks like, things like that. So I will say that in my experience, DataCamp versus us, DataQuest, is more geared towards teaching with kind of a hybrid model, potentially, of video and some hands-on learning. But we are very much weighted in the opposite direction of essentially all hands-on learning and no video, unless you count GIFs or GIFs, however you pronounce them, as videos, which I probably would not. So yeah, I would say that's probably the 2 biggest differences. The level of feedback that you'll get will be significantly more, most likely. And what you'll find is that there will be a lot of places on DataCamp that will have video in certain topics. And if you like that, that's fantastic. And I encourage you to do that. But if you prefer doing the reading and doing the sort of application aspect very quickly through those lessons, like very soon after you've read through that information, then I would recommend probably DataQuest as being a better option for you.
Okay, thank you. Do you see the question from Martin? He asked, do you have any advice on project organization, for instance, software used? How do you usually start off personal projects?
Oleg, do you have any thoughts on this one?
I have a lot to say on this. I think it's really about getting into this mindset of identifying, seeing problems around you. And I don't think we can give any particular advice on what are good personal projects, but finding a house and getting some pricing data is a very good example, because that's something all of us face, but I'm sure that there is something more specifically. The way I would approach it is, if you want to have personal projects as something that not just solves your personal problem, you should look at projects where you can actually demonstrate a little bit of each of the components, a little bit of each of the part of the data science journey. So you would need to do some analytics, you would need to do some data exploration, some data preparation, some predictions, some model, some results interpretation, and you will need to present it ideally in some blog post, because it's also something is very important for data scientists, presenting the results of our work. And in terms of the software used, I think if you're starting your career, it is very important to try different things. And I think Joseph mentioned it. You mentioned it on your talk as well, because you want to learn different things, and you never know whether you like a data science job at all, or whether you like being a machine learning engineer versus product data scientist until you try it. So just try different software. If you try Python, just go ahead and try R. And in the broader sense, try as many different technologies as you can.
Okay, and there's just coming a new. Or do you have something to add, Joseph? Or
I was just going to contribute that, you know, if there's any kind of personal hobby of yours that you've always wanted to explore further and potentially discover more about quantitatively, it really is like you can really start anywhere, which I know is difficult. What I say personally is, I started with Python. I picked that because I knew that a lot of companies out there could use Python, and Python is very multi-purpose. You can use it for lots of different contexts and lots of different projects. So I would say, you know, starting with something, at least if we're talking about tools or languages, what have you, starting at something like that that's going to be applicable to a lot of different contexts is probably better for you. And then, yeah, if you know, like Oleg had mentioned, and I think it's kind of coming up here in the questions as well, like Kaggle is great. I always use the anecdote that our CEO actually got his first job in data science off of winning a competition on Kaggle many years ago as well. So yeah, I always encourage people to do that. Because it's a really great way to kind of show that you're able to apply these ideas in new ways, and there's always kind of new stuff coming through. So there's so many different projects that you could apply this to, that I would just say kind of pick one and start. Become frustrated, because you will become frustrated, and as soon as you work through that frustration, you'll get to the other side at this kind of light bulb moment where things will start to make sense and things will start to sort of fit together. So yeah, I would say maybe the most important thing may not be knowing exactly where to start, but knowing that the challenge will be there and being like ready to push past the frustration, you know, the initial challenge.
okay, thank you. And then there were the questions. I think they are more for you, Oleg. If it's suitable to put the Kaggle challenge submissions to your CV, like, is that something that you should include? And as well, is it important to have in the end like certificates from DataQuest or DataCamp, or is it enough to just go through the courses, or should you spend the money, have the certificate, and kind of a proof on your CV?
Yeah, I think we might disagree with Joseph on this one. When I think about CV, I think that the audience of your CV is usually a recruiter. it's not the hiring manager, it's not your fellow data scientist in the company that you applied for, because they will actually have an opportunity to test your skills, to talk to you, and ask about your previous experience. So CVs is just something that gives you a ticket to an actual interview with a professional. So, and the way the recruiters look at CVs is this fast and easy classification model, where they just check if you pass whatever number of years of experience, whether you mention the relevant technologies. Anything extra might help. Any extra certificates might help you stand out a little bit from the other candidates. But I would really focus on, I would not think about DataCamp or other courses as a certificate. It's really that I would focus on learning and being able to highlight your experience, being able to highlight your skills, and have some nice stories about how you apply data science to solve some real life problems.
Okay.
Yeah, if I could weigh in on that as well, Oleg, as far as like, I actually completely agree with you, to be honest. I think that in my experience with talking with students who have been through either our courses on other programs, other boot camps, even like in-person classes, degrees, etc., and I mean like online degrees potentially, what they found is that the credentialing is typically only, it has limited use. It does have limited use. And what I mean by that is that most likely, exactly what Oleg is talking about is likely true. If a recruiter has that in their criteria, that they're scanning and searching your CV for that type of certification because it's important to them for that role, it may put you a half step up above another candidate, maybe, but realistically, by and large, at least with my experience and the folks that I've spoken with, they say, what I gained from the courses is vastly more important and has helped me way more than the actual certificate at the end. The certificate at the end just proves that you actually did it, but in a lot of, for a lot of employers, they're not particularly focused on that aspect, and they're way more focused on other aspects. For example, like, can you show that you've worked through a problem and exactly the steps that Oleg talked about? Can you show that you can process and clean data? Can you show that you can compile that data in a way that makes sense? Can you show that you can interpret that data and convey it to someone, or convey those findings in a way that they understand and can relate to? So I think those types of things are infinitely more important than the piece of paper that you may get at the end.
Okay, all right. And then there's one specific question from Mark. He asked, Julia has been on the rise as a new programming language. Do you see it becoming more popular in data science as well? And would you recommend starting out with that as well? What's your opinion on this? Oleg.
Okay. To be very honest, I heard of Julia, but I'm not familiar with it. Mm-hmm. I think it's definitely worth learning about new technologies and just trying to see what it is. In terms of whether it will become popular in data science and would I recommend starting out with this, approach this question as a data scientist. How many job descriptions require the knowledge of Julia right now? Just, I don't know, download 10 or 20 and just get this percentage to get a sense of the market share. Look at Google Trends and see whether it's growing at a fast pace or not. I don't know. I would just think about it as a data scientist, but I cannot really tell you if I can't really answer the question about the technology itself.
Okay, all right. Then I have a question for you, Joseph. Do you also approach universities about including DataQuest into their curriculum as DataCamp does? For example, offering student accounts?
Yes, absolutely. So basically, for most colleges and universities out there in the world, what our offering is actually pretty similar to DataCamp's offering, if you're familiar with theirs, which is that we both offer free access to anybody who is part of like a formal education program in that type of context. So if your professor, for example, is teaching a course in data science and they're not yet using us, they can reach out to a person like me, for example, and start using and integrating us with their existing curriculum. It's actually something that, you know, with the circumstances this year, with the pandemic, has become pretty important for folks who were not teaching virtually, who have gone to either hybrid models or totally virtual, that a lot of the content that these professors had developed over many, many years and years of doing lecture-based classes wasn't really designed for teaching virtually. And that's no one's fault, it just is a matter of the situation. So with the possibility of doing that, we've definitely been reaching out to a lot more folks. If you're familiar with folks who are interested in doing that, let them know that it's perfectly free and that we're happy to set them up with that type of thing. But yes, we are always exploring those types of partnerships, and that's really something that we've been pushing for in the more recent few months.
Okay, all right. In case you want more, like from your answer, just retype your question as well. So that's also a possibility. And then we have another question from Alexander. He asks, for a future data analyst, would the execution of R Python code in conjunction with BI tools like Tableau or Power BI via APIs, for example, TabPy, be a valuable skill demanded on the job market? That's quite a long question. You can also read it in the chat. Yeah, so feel free to give your
I could just weigh in on this quickly in that I think that, so Python I think is going to be relevant foreseeable future still. I don't see it going away anytime soon. It's still very used in a lot of different contexts. It's still very popular. So definitely, like I said earlier, a great place to start, Alexander. But with other tools like Tableau, Power BI, these types of things, I think those are also fantastic to have, but these are going to really depend on the type of role that you're going into, the type of organization that you work with, and the way that they approach data within that team or within that organization. So that would kind of be my take, is that I think it's going to be, for some of these other tools, more specific to the roles that you're looking at, or potentially to the industries that you're looking at as well. But again, you know, I would look at your ideal job descriptions, like Oleg had brought up, and see, you know, are these keywords that you're seeing very frequently for the ideal role that you'd like to end up in, you know, and if so, that's where I would really spend your time focusing, because I know for a fact that at certain organizations, on certain teams, those tools are extremely popular, and for others, they're not even used remotely at all. So yeah, it really varies a lot.
Okay, all right. And Oleg, you already like re-asked. Okay, so the question, you already read that, right? So Regina asked if how should somebody deal with a non-linear CV? So if there are some gaps and things that you have done, but not necessarily important for the job you apply to.
I think that's a very important question. I will quickly follow up on the question about Julia and technologies that will be in demand in the future. This is actually a very good example of a personal project. Just analyze the keywords and job descriptions, analyze how it changes over time, write a blog post about this, get the data, do some exposure analysis, find some insights. It will definitely make you stand out from the other candidates. So moving to the question from Regina, non-linear CVs, having worked on a lot of different things, it is usually required to have no gaps in the CV, but a lot of it might not be relevant for the role. I actually really like CVs when people have background in something different from data science, because this is where the interesting stuff happens. Like if someone transitioned from an accountant to a data scientist, they have a very different perspective, a very valuable experience that no other data scientist has. And if you transition from literally anything not related to data science, and especially not tech, this is definitely your advantage. Present it as your advantage. Think about the things that you can apply. And I see my presentation today was really about trying to apply a knowledge of machine learning to an area where machine learning is a little bit out of context, because people don't think about recruitment as a machine learning problem. And if you just apply your point of view from your previous jobs not related to data science, if you present it as your advantage, I think this will help you stand out from other candidates that might have 2 years more, 2 years longer data science experience. But it's always the learning curve, right? In the beginning, it's always steeper than later. So this is definitely not a blocker, and I would encourage you just to think about the way of presenting this as your advantage. Gaps in the CV, I think this is more for recruiters. I don't know. I don't see anything bad in gaps in the CV, especially this year. A lot of people were laid off. A lot of people are taking sabbaticals. Everyone has their own personal situation. There is a lot of articles about gaps in the CV. Yeah, I think if you think about recruiter as a robot that looks for a specific keyword, worked as a data scientist with Python for at least 3.5 years, and you were a software engineer for 10 years before it, then probably you need to adjust something. But this is a very bad situation when people make hiring decisions with strict rules. So I think it's not a problem at all.
Yeah, if I could just weigh in on that, like I agree with what Oleg is saying about gaps. As a person who has multiple gaps in their work history, because I've taken sabbaticals at this point a couple of times, I think the most important thing in my experience has just been that you're able to talk about it, and that you're able to sort of be upfront and talk about, if there is something that you did during that time that could be relevant to the role, fantastic. If there wasn't, say that as well, and I think that's okay. And most interviewers will understand that. Most recruiters will understand that as well. And so, yeah, I do hope that folks aren't taking, really taking that into account in their hiring process, and that they're really going to look at what you have done rather than what you have not done. That's sort of a strange approach, right? But I would just say, yeah, just be willing to be upfront and talk about it. And if there are things that you did during that time that could be relevant, definitely bring those up too.
Okay, thank you so much. There is a next question from Elisa. She asked, what advice could you give to statisticians or economic researchers who want to leave academia and want to get a job in data science? How can they sell their skills as compared to the more technical skills of data engineers or computer scientists, for instance?
I think this is a great question. Very related to the previous one about gaps in the CV and diverse background. I know a lot of good data scientists that have background in economics or social sciences. Many data scientists that had long history of working in academia and then transitioning to commercial experience. To sell your skills, well, first of all, if you think about this radar chart that I showed in my presentation, whatever role you choose, whether it's a product data scientist or machine learning data scientist or inference data scientist, you still need to have some horizontal knowledge about the basics, right? So if you have, I assume you have some basic knowledge about programming, you have definitely advanced statistics skills, you definitely know about machine learning given your experience. Maybe you need to learn a little more about coding best practices. Just make sure you cover the basics, and then it really depends on what kind of role you're going to apply, because with experience like yours, it will be very hard to get a job as a data engineer right away. Maybe you should apply as some inference data scientist first, and then try to find opportunities within the company to transition to something more interesting. And this is the story of my life. I've been working in tech for 12 years. I started as a software engineer. I worked as a software engineer for 2 years. Then I moved to analytics role for 3 years. Then I moved to data engineering role for another 3 years. Then to a data science role for 3 years. Then I became a people manager and worked as a data science manager for another 3 years. Usually once you get into a company and once people trust that you can solve problems, it's not such a big of a problem to transition from data scientist to data engineer. And I think in your case, if you're transferring from academia to something heavier on the engineering side, just try it. Again, try and create some personal project for yourself. Try programming. Try using version control. And maybe actually this is not what you like. If you do like it, then you will enjoy working on these personal projects.
Joseph, you have something to add, or?
Yeah, I would just say that I think it's about framing your strengths. And again, this is similar to what Oleg has said, but basically to drive the point directly home, it's that as a statistician or as an economist, as an economics researcher, you have a really fantastic set of skills that somebody coming from maybe like a software development or computer science background may not have. So for example, maybe your skills are more at the latter end of the pipeline that Oleg was talking about, where maybe you're really, really great at presenting your analysis and knowing how to do data visualization or things like that, because that's just been a part of roles that you've had in the past. That's been part of maybe what your research has been a part of. And so that's what I would focus on, is the fact that you likely have skills within this pipeline that you're really, really effective at, that other people may be more effective at, say, the front end of the pipeline, like the actual data cleaning aspects or other computational aspects or what have you. So yeah, really I would say just focus on your strengths and understand how those skill sets will still be applicable and still relate to the roles that you're applying for. I do agree with Oleg as well that once you get in as, for example, a data analyst, and you can prove that you have those skills at a level in that pipeline, that they'll want to improve your skills in the rest of that pipeline. So if there's a new language that they want you to learn or a new tool that they want you to learn, if you're really effective in these other aspects, they'll want to build you up to that person to help you, achieve that career goal. So yeah, if it's a good company, I will say that they will foster that type of environment really effectively. And then just through the hiring process, it's going to be really understanding how to relate all the things that you've already done and understand that they are still incredibly relevant to the types of work that will happen in data analyst roles, for example.
Yeah, maybe just try the mock interview with NextRound.cc, right?
I highly recommend it, because it will really help you understand how good or bad you are at technical skills, and maybe you're not bad at all.
And then we have, I would say, like the last final question regarding the time. So Benjamin asked, like, from Elisa's standpoint, so the question you just answered, how do you decide if your purely technical role or rather management role is more suited for you?
I can start here. I think the best is to start as an individual contributor, start leading informally within the team, and then just see if that's something that you like, transition to a management role. Because these are two very different, these roles have very different job content. Being an individual contributor, data scientist or data science manager, I would start as a data scientist, apply for data scientist role, and start helping people around you, start organizing things around you. If you enjoy it, if people appreciate the work that you're doing on this front, then you will transition to data science manager role successfully.
Okay. Joseph, you want to add something, or?
Just a big +1 to that.
Okay.
Yeah, that was perfect.
Okay, well, so unfortunately the time is already up, and we will continue with like the workshop sessions for beginners and advanced workshops. Thank you so much to Pittsburgh, to Amsterdam, to you, Oleg and Joseph, for joining us in this international session. Yeah, so everybody check out DataQuest and NextRound.cc. And yeah, thanks a lot for sharing your experiences. It was really nice insights. I think, yeah, people appreciate it. You get a lot of thank you in the chat. Okay, so, well, see you at the CorrelCon, yeah? Have a good day.
Thank you so much. Appreciate it.
Thanks for sharing. Bye.
Bye.